Ever feel like the world's changing faster than you can keep up?
Yeah, it's hard.
Well,
Oh, okay.
buckle up
Mhm.
because we're diving into quantum science today,
Oh, it's fascinating.
a field that's about to reshape everything
Absolutely.
from how we work to how we learn, and even the very meaning of online security.
A true paradigm shift.
Absolutely. To guide us through this complex landscape, we're turning to an essay
Okay.
by Jörg O. Schneeppert titled Quantum Technology, Folgen für Arbeit und Bildung, which translates to quantum technology, consequences for work and education.
Wow.
Our goal today is to unpack Schneeppert's insights and help you understand what this quantum revolution means for your future.
Schneppet does a great job of laying out the core concepts
Yeah,
of quantum mechanics
yeah, he really does.
in a way that's accessible, even if you don't have a physics degree.
Right. And one of the most mind-bending ideas is this concept of superposition.
Right.
It basically means a particle can exist in multiple states at once until we try to measure it. Think of it like a spinning coin that's both heads and tails simultaneously until it finally lands.
It's a probabilistic state where all possibilities coexist, and this isn't just some theoretical quirk, it's the bedrock of what makes quantum computers so powerful.
Okay, so let's talk about quantum computers.
Okay.
Schneeppert really emphasizes their potential to be game changers. He points out that they use these things called qubits, which can be both 0 and 1 at the same time thanks to superposition.
Exactly. Unlike classical computers that rely on bits, which can only be either 0 or 1, quantum computers leverage this both at once state of qubits to explore a massive number of possibilities simultaneously. This allows them to solve certain types of problems exponentially faster.
So it's not just that they're faster, it's a whole different way of approaching computation. What's fascinating is that Schneeppert highlights how this isn't just science fiction anymore. Companies are already using quantum computers to solve real-world problems. Volkswagen, for instance, is using them to optimize traffic flow in cities.
And they've seen some remarkable results. Schneeppert mentions how they were able to significantly reduce congestion in Lisbon during peak hours using quantum algorithms. It's a great example of how this technology can have a tangible impact on our everyday lives.
And it's not just traffic. Goldman Sachs is exploring quantum computing for complex financial modeling, and Roche is using it for drug discovery.
This is just the tip of the iceberg.
Yeah, yeah.
As Schneeppert points out, the potential applications are vast, from personalized medicine to developing new materials and even tackling climate change through complex simulations.
It makes you wonder what industries won't be touched by this technology.
Exactly. It's hard to imagine any industry that won't be affected in some way.
Yeah,
It really is hard to predict exactly how things will unfold.
right.
But the possibilities are both exciting and a little daunting. But let's shift gears for a moment and talk about security, because as quantum computers become more powerful, the question of cybersecurity becomes even more critical.
That's a great point. If these computers can crack complex problems, couldn't they also be used to break the encryption that protects our data?
Absolutely. And that's where quantum communication comes in.
Okay.
Schneeppert highlights this as another key area where quantum science is making waves. The goal is to create ultra-secure communication networks that are essentially unhackable.
Unhackable networks, that sounds almost too good to be true.
It might sound like science fiction, but it's based on the principles of quantum mechanics, specifically something called quantum key distribution, or QKD.
Okay. I'm intrigued. How does QKD actually work?
Imagine you want to send a secret message to someone. You and the recipient both need a shared secret key to encrypt and decrypt the message. QKD uses photons, which are tiny particles of light, to transmit this key. The key is encoded in the quantum properties of these photons, like the polarization.
So it's like sending a secret code using light signals. But how does that make it unhackable?
The key is that any attempt to intercept or measure these photons would inevitably disturb their quantum state, due to the fundamental principles of quantum mechanics.
Interesting.
This means you'd immediately know if someone was trying to eavesdrop on the key exchange.
So it's like having an alarm system that goes off if anyone tries to peek at your message. That's brilliant.
It is, and what's even more remarkable is that this isn't just theoretical. China, for instance, has already launched a satellite called MISSIS that's specifically designed to test satellite-based QKD. They're experimenting with global unhackable communication networks as we speak.
Wow. So quantum science isn't just giving us powerful computers, it's also paving the way for a future of incredibly secure communication.
Right.
But what about the impact on us regular folks? I mean, how is all this going to affect the job market? Schneeppert seems pretty concerned about that.
He is, and rightfully so. The quantum revolution is going to create a whole new landscape of jobs,
Right.
many of which we can barely even fathom right now. We're talking about entirely new skill sets and specializations.
Like what? Give me some examples.
Well, for starters, we're going to need quantum engineers. These are the highly skilled individuals who will design, build, and maintain the quantum computers themselves.
I imagine that requires a very specialized skill set.
Absolutely. It's a blend of physics engineering and computer science. Then you'll have quantum software developers who will create the algorithms that run on these quantum computers. It's a completely different type of programming that requires a deep understanding of quantum mechanics.
So learning Python or Java won't cut it for this kind of programming.
Not quite. And let's not forget about the security aspect. As quantum computers become more commonplace, we'll see a huge demand for experts in quantum cryptography. These are the people who will be responsible for safeguarding our data and communications in this new quantum era.
It sounds like a whole new frontier is opening up.
Mhm.
But this begs the question, are we even remotely prepared for this shift? I mean, is our education system equipped to train people for these quantum jobs? Schneeppet seems to think this is a major concern.
He does, and I share his concerns. There's a growing awareness that we need to make some fundamental changes in how we approach education if we want to keep pace with these advancements. We can't just wait for the quantum revolution to happen. We need to actively prepare for it.
So what needs to change? What does Schneeppet
Yeah.
recommend?
Well, one of his key recommendations is to introduce quantum mechanics concepts much earlier in the education process, perhaps even at the high school level.
Quantum physics for teenagers, that sounds like a pretty tall order.
It may sound ambitious, but it's essential if we want to equip future generations with the foundational knowledge they'll need. It's about fostering a generation that's not intimidated by these concepts, but rather sees them as exciting avenues for exploration.
I like that. So start early and build that foundation. What else?
Schneeppet also argues for more interdisciplinary university programs that combine physics, computer science, and engineering. The quantum field requires a diverse set of skills, so it's crucial to break down those traditional academic silos and encourage cross-disciplinary learning.
So no more working in isolation. We need to create environments where physicists, programmers, and engineers can collaborate and learn from each other.
Exactly. It's about fostering a more holistic approach to education that recognizes the interconnected nature of these fields.
It sounds like a pretty big challenge.
It is.
But what about those of us who are already out of school?
Right.
I mean, I didn't exactly major in quantum physics.
Yeah.
Are we just going to be left behind?
Not at all. One of the most encouraging trends is the rise of online courses and virtual labs that make quantum knowledge much more accessible than ever before.
So even if you have a full-time job and a family, you can still learn about quantum science.
Absolutely. There are some fantastic resources available,
Wow.
from platforms like Coursera and edX to more specialized programs offered by universities and research institutions. It's never been easier to delve into this field, even if you don't have a formal background in physics or computer science.
That's reassuring. But Yorgo Schneeppet does seem to emphasize a sense of urgency. He argues that we need to act now to bridge this quantum skills gap.
He's right. The quantum revolution isn't some distant event. It's happening right now, and it's going to affect everyone, not just scientists and engineers.
So it's not just about learning how to code quantum computers. It's about understanding how this technology is going to transform industries and reshape the way we live and work.
Precisely. It's about developing those adaptable skills that will be crucial in a world where change is the only constant.
So what can our listeners do to start preparing for this quantum future? What concrete steps can they take today?
Well, I'd encourage everyone to start by reading Schneeppet's essay, Quantum Technology: Consequences for Work and Education. It's a great starting point for understanding the key issues at play.
Agreed. It lays out the landscape in a very clear and insightful way.
From there, explore those online resources we talked about, take a free introductory course on quantum computing, or delve into a specific area that interests you, whether it's quantum cryptography or quantum algorithms. There's a wealth of knowledge available online.
It sounds like there's a quantum rabbit hole waiting for anyone who's curious enough to dive in.
Exactly. And don't be afraid to reach out to local universities or research institutions. Many of them offer public lectures, workshops, or even open houses that can give you a glimpse into the world of quantum science.
It's about fostering that sense of curiosity and embracing lifelong learning, because the future, as Schneeppet so aptly points out, is not preordained. It's shaped by the choices we make today.
Well said. And who knows, maybe one of our listeners will be inspired to make the next big breakthrough in quantum science.
That's a great thought. So to our listeners, we challenge you to do your own mini deep dive into the world of quantum science. Explore the resources we've mentioned, consider the implications for your own field, and start thinking about what steps you can take to be prepared for this exciting and undoubtedly transformative future.
Because one thing's for sure, the quantum future is going to be fascinating.
And as always, keep those curious minds engaged and keep exploring the world around you. Until next time, fellow knowledge seekers,